A sleepy German tourist island in the Baltic Sea is poised to be changed by one of the world's most significant infrastructure projects. Hello, and welcome back to INO 6, where we discuss innovation, construction, and future civilization. In today's video, we'll see the upcoming megaproject that's going to shape the Trans-European Transport Network. Let's have a look at the insane scale of Europe's new megatunnel. So, without wasting time, let's get started. This island of Fehmarn is located close to the German peninsula and is split from the southern coast of Denmark by the Fehmarn Belt, a 20-kilometer length of sea. A tunnel between the two countries is being built to provide the missing piece in a transcontinental roadway that would transport hundreds of thousands of people each year and produce billions of dollars in income. The Trans-European Transport Network is a network of highways, trains, and sea channels that connects every corner of Europe. The ScanMed Corridor, the network's core vertical access that runs 5,000 kilometers from Malta in the Mediterranean to Finland's Arctic tundra, is one of the essential routes. It drills into alpine rock and passes frozen seas along the way. But if you continue north through Germany, something unusual happens. Instead of going to Sweden, you must take a 150-kilometer loop around Denmark, which leads back to that short, unassuming strip of water, the Fehmarn Belt. The Fehmarn Belt might not appear to be much, yet it has thwarted some of the world's top engineers for over a century. Until now, that is. The Øresund Bridge is one of rare municipal engineering feats, a massive structure whose architecture and engineering work ideally to create a genuinely iconic piece of infrastructure. It was immortalized in the 2011 play The Bridge, connecting Denmark with the southern Swedish city of Malmö, and it was during the planning of the crossing that Sweden had a tremendous idea. To get from Sweden to Central Europe right now, take a train to Malmö. This takes you across the Øresund Bridge to Copenhagen, where you change to another train that takes you to Hamburg, Germany. It takes roughly 5.5 hours on a high-speed rail and significantly longer on a freight train. Germany is Sweden's second largest export market, so this is significant. The Swedish government saw a diversion at the Fehmarn Belt and negotiated a deal with Denmark. The Swedes would help build the Øresund Bridge in exchange for Denmark agreeing to look into creating a new link at the Fehmarn Belt. Thankfully, it wasn't as terrible as you may assume. There's been talk of creating a railway between Hamburg and Copenhagen since the 19th century, quaintly dubbed the Vogelflugelein, or Bird Flight Line. But nothing happened until the 60s when a bridge was built to cross the short stretch of water between Fehmarn and mainland Germany, known as Fehmarn Sound. That route was then extended to a new ferry port at Puttgarden, bringing trains to the water's edge. The trains were loaded onto ships and transported across the Fehmarn Belt to Denmark. The whole event moved at a snail's pace. The diesel trains that operated the route were slower than modern trains, and the ferry took more than 45 minutes. For years after that, there was talk of upgrading the road to a fixed link, but it wasn't until Sweden put down the gauntlet that things became serious, and in 2008, the Danish and German governments signed a deal to begin work on the Fehmarn Belt fixed link. The proposed crossing would have a 4-lane highway and 2 rail lanes serving freight and high-speed passenger trains. Denmark would fund the entire project, collecting tolls and operating the onshore enterprises. Separately, Germany would improve the road from Fehmarn to the mainland to accommodate the increased trains and traffic, including constructing another short tunnel crossing the Fehmarn Sound. The transportation network would undergo a once-in-a-generation makeover. The Hamburg-Copenhagen corridor would be transformed into a high-speed road and rail route. The Swedes would get a shortcut to the continent, a significant detour would be removed from the ScanMed corridor, and the more comprehensive Trans-European Transport Network would be changed. The only thing standing in their way was the sea. A bridge was the most obvious answer. Feasibility studies has been undertaken as early as the 1990s, and as the Øresund crossing showed, Denmark was rather adept at creating them. The solution they devised was a 3-kilometer-long cable-stayed bridge that sat roughly 65 meters above the ocean, allowing ships to pass underneath. The cable-stayed design was similar to the Øresund Bridge, only it would be 3 times as long, and this is where the troubles began. The Fehmarn Belt isn't a wild, dangerous ocean, but it's still awkward. It's slightly under 20 kilometers broad, quite deep in spots, and the soil isn't ideal for construction. To deal with the length of the Fehmarn Belt, the bridge would have needed spans of over 700 meters, which is the longest span ever erected for a combined road and rail bridge. The aim was to build 3 massive pylons, each about 300 meters tall. Those would require foundations to be built at sea in depths of up to 25 meters. When you combine poor soil conditions with a busy shipping lane, you have an engineer's nightmare. The bridge was ruled out after a thorough evaluation of the possibility of cost overrunning and the technical complexity of the building. If you can't go above, you have to go beneath. The Fehmarn Belt on the other hand, is the ideal length for a tunnel. Bored tunnels are advantageous for several reasons. First and foremost, they do not disturb anything above ground. That's why they're typically used for subterranean railways in cities. Still, they're also ideal for a place like Fehmarn, which has a sensitive environment that could take years to recover from all the disruption created by constructing a bridge. They are pricey initially, but they become less so as you travel deeper. So the crew set out to explore the idea of boring a tunnel through the Fehmarn Belt, but that too ran into trouble. A tunnel boring machine, or TBM, digs bored tunnels. The width of the tunnel depends on the TBM. However, machines roughly 7 meters wide were employed on London's new Elizabeth line. Because there is just one track per tunnel, they are suitable for underground railways. However, Fehmarn requires a railway, a highway, and an access tunnel. That could imply boring 5 different tunnels at a cost 5 times as high. That's not right. That is not all. Because the wheels are composed of steel, there is extremely little traction and very little of a train's surface area lies on the track. That's fantastic on flat tracks. It's one of the reasons trains are so fast and efficient. However, traveling uphill becomes more difficult. The average mainline train can increase its speed by 2.5%, or 1 in 40. For every 40 meters of track, the train can move 1 meter upwards. At its deepest point, the Fehmarn Belt is around 40 meters deep, and any bored tunnel would have to be at least 10 meters below that. That would make the tunnel highly lengthy for a train to travel through it, under the ocean, and back up the other side. A shorter tunnel would result in a steep railroad track, and any train would likely not make it. So, with a bridge and a bored tunnel ruled out, you would assume it's time to call it quits. Fortunately, there's still one option: the Immersed Tube Tunnel, or IMT. IMTs are composed of prefabricated concrete parts rather than drilling through the dirt. These are then transported to a trench excavated in the seabed, submerged, and sealed together. Once laid, the entire structure is covered with earth, and you have a tunnel. An IMT is an excellent solution for a location such as the Fehmarn Belt. It's shallower than a bored tunnel, so trains can easily pass through, and it's a lot cheaper. You sidestep the technical complications of creating a bridge, and once completed, it offers no risk to shipping. However, as you might guess, there is a catch. IMTs are typically utilized for relatively short areas, such as rivers and harbors. Continue driving across the Øresund Bridge towards Denmark until you reach a man-made island and suddenly plunge down into the Drøgen Tunnel. It's only 4 kilometers long, but it's one of the world's longest IMTs. The Fehmarn Tunnel will be 5 times the length of the current one. So, how do you construct something so massive? It begins at the massive construction site in Rodbyhaven on the Danish side of the Fehmarn Belt, managed by the Danish state-owned company Fehmarn AS. It's so large that simply building the workspace took them 2 years. The massive facility where the tunnel pieces will be built is the show's centerpiece. It's one of the largest factories ever erected in Denmark, spanning 500,000 square meters or almost 200 football fields. That magnitude is required for the production lines producing the 89 concrete tunnel pieces, each of which is 220 meters long, 12 meters high, and 40 meters wide. These factories will be operational 24 hours a day, 7 days a week, for 3.5 years once wholly operational. When construction begins, aggregates and materials will be carried to a specially constructed work harbor and then transported by conveyor belt to the factories where the elements will be cast. Because each element is so huge, it will be built into 9 smaller segments, each of which will take 36 hours to cast. Once a complete tunnel element is built, it will be rolled out of the plant and transported to a massive dry dock, where it will be floated and transported out to sea where the tunnel trench will be created. Massive ballast tanks are filled with water to sink the 73,000-ton concrete tube elements to the ocean floor, where winches will guide them to within 15 millimeters of their targets. Once all the elements are in place, the trench is backfilled, and the tunnel is covered in gravel to protect it before nature takes over and covers the gravel bed with sand. Once the tunnel framework is in place, the modest task of putting a highway and train through it begins. Before it opens to traffic in 2029, the tunnel will also be outfitted with ventilation, supports, and monitoring systems. Thousands of autos and hundreds of trains will pass through this tunnel every day once it's completed. The predicted economic gains are enormous, but it all comes at a high cost. The project's budget is now set at $7.5 billion US. $500 million comes from EU subsidies, and the rest comes from a loan from the Danish state. Thus, Danish taxpayers will not pay a dime. Denmark stands to benefit significantly from this project. Cars are scheduled to be charged approximately the same as a ferry, around $100 for a round-trip ride, which is expected to produce around $4 billion in profit over the tunnel's first 50 years of operation. That's it for today. Hope you liked the video. Share it if you did. Like and comment on the video that you want to see next on our channel, and subscribe to see our future videos. We'll see you in the next video. Till then, keep watching.